Module 4, Lesson 23, True and False Number Sentences. For those of you who have perhaps watched some of the other Module 4 lessons, I recorded those about 2 years ago. Our district's learning targets have changed, so I have updated learning targets in the presentation to match our new learning targets. We are focused on the standard or the target of using substitution to determine whether a given value makes an equation true. And the I can statements for this lesson, I can show and explain what the equality and inequality symbols represent. So a little bit of vocabulary focusing on these particular symbols. And I can determine if a number sentence is true or false. So we'll do a little bit of evaluation. So we're going to run through a set of statements, and we are going to decide if they are true or false. If a statement is false, we need to explain our reasoning. Why is it false? First, the Earth orbits the Sun. This is a true statement, so I don't need to do any explaining of my reasoning, although if we wanted to, we can have a big long discussion about all of the evidence that has been presented to support this statement. George Washington was the first president of the United States. This is true. When we talk about things being true or false, we need to have factual evidence or reasoning to explain it. We could actually do some research in the history of the United States. We could actually read about who are the presidents of the United States, and we could find that George Washington is the president. There are only 25 hours in a day. This is a false statement. Without getting too much into the science side of things, a day is closer to a 24-hour time period. So we've moved away now from true and false statements and other subjects, and now we're going to look at some mathematical statements, and we're going to ask, are they true or are they false? Well, I have 3 plus 3 on this side, and the question is that the same, or does it have the same value as 6? I could draw a tape diagram showing 3 and 3, and I could draw a tape diagram showing 6, 2, 3, 4, 5, and over here the total is 6, and over here the total is 6. So I can say that this is a true statement. 2 plus 2 equals 5. So when I evaluate this 2 plus 2, I've got 2, and I've got 2, and over here I'm supposed to have 5. Over here I only have 4 units. Over here I have 5 units. This is a false statement. Now this statement could be altered to be true if I were to change one of those 2's to a 3. Now I have 2 plus 3, and I have 5. So as written, 2 plus 2 does not equal 5. And an explanation for why it's a false number sentence: the expressions on both sides of the equal sign should evaluate to the same number. This equal sign means that what is over here on the left-hand side is of equal value to what is here on the right-hand side. So for this number sentence to be true, either the first or second addend, this 2 or this 2, would need to be changed to a 3. Now we're going to build some of the vocabulary. We're going to take a look at each symbol and provide an example. So we have the equal symbol, and equals means equal to, meaning having the same value. And an example is 4 7/8 is equal to 4 875 thousandths. This is a greater than symbol. Notice that it is open on the left-hand side. And we use that when we are comparing, and our first item that is compared is of greater value than our second item. 5 1/4 is greater than 4 7/8. This is the less than symbol. Notice that it starts closed and then it is open on the right-hand side. So our lesser term comes first, followed by our greater term. 4 1/2 is less than 4 7/8. This next one may be new to many 6th graders. we have a hybrid, meaning there's two parts in this symbol. We have the less than symbol, but we also have part of the equals symbol. And this is named less than or equal to. So for example, 4 and 7/8 is less than or equal to 4 and 7/8. In this case, it's equal to the 4 and 7/8. Or it could also mean less than. 4 and 7/8 is less than 5. So this is a combination. We can use numbers that are less than or equal to. And the next one is the opposite with the greater than or equal to. Once again, we have the greater than symbol, and we have part of that equals symbol. So we can have statements where we are greater than, so we can have equal to. 4 and 7/8 is equal to 4 and 7/8, or 4 and 7/8 is greater than 4. All right, taking a look at some examples here. For each equation or inequality that will be displayed, write the equation or inequality and then substitute 3 for every x. So we would copy this down, and then we're going to substitute a 3 in. And then we're going to determine if, when we substitute the 3 in, we have a true number sentence or a false number sentence. And we'll provide some kind of explanation for the truth or false of the statement. So I've got 5 plus x. I substitute the 3 in, so I replace the x with the 3, and I am left with 5 plus 3 equals 8. Now I need to evaluate this equation that has an equal sign. 5 plus 3 is 8 equals 8. Is that a true statement or a not true statement? Is it true or is it false? Well, I have a value of 8. I have a value of 8. I can say that this is a true statement. I could prove it with a tape diagram. 1, 2, 3, 4. 1, 2. So here is my 5, and here is my 3, and all together, here is my 8. So 5 plus 3 is equal to 8. And of course, I've got some explanations that I've copied and pasted in here. Each expression on either side of the equal sign evaluates to 8. I do enjoy using tape diagrams to prove or disprove these. Here we have 5x equals 8. So we are going to substitute in the 3. And it's important at this time to remember that when we have something written like this, what we have is a multiplication problem. This 5x is the same as 5 times x, or it could be written as 5 times x. Or if you wanted to use the commutative property, you could write it as x times 5. So when we substitute in the 3, we have 5 times 3. And the question is that equal to 8? Well, I know that 5 times 3 is 15, and I know that 15 is not equal to 8. So I'm going to state that this is false. And if I had to prove this with tape diagrams, I could do 5 of 3. So I have 5 of 3, and I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, 8 was clear back over here. So 15 does not equal 8. This is a false statement. So now we have a 5 plus x is greater than 8. So once again, I'll substitute. 5 plus 3 is greater than 8. And this would be an inequality. It's not an equation. It doesn't have that equal sign. What we have here is something that is not equal. So if we take a look here, 5 plus 3 is 8. And I am answering the question, is 8 greater than 8? And the answer is no, it's not. If I were to draw a picture of 8, and this is my 8, and this is my 8, they are equal to each other. One 8 is not greater than another 8. So I'm going to say that this is false. 8 is equal to 8. 8 is not greater than 8. So each expression on either side of the inequality sign evaluates to 8. However, the inequality symbol states that 8 is greater than 8, which is not true. And we've already proven that 8 is equal to 8. So here we're going to have, once again, a multiplication. We've got 5 multiplied by 3 is greater than or equal to 8. And if I evaluate 5 times 3, I have 15. And I am answering the question, is it true that 15 is greater than or equal to 8? And yes, that's true. And we already drew some tape diagram earlier, but 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here is 15. And if I take a look, 1, 2, 3, 4, 5, 6, 7, 8, there's 8. 15 is greater than the 8. So I'm using the greater part to state that this is true. 15 is greater than 8. All right, 5 plus x is greater than or equal to 8. Substituting again, 5 plus 3 is greater than or equal to 8. This evaluates to being 8, greater than or equal to 8. Now when we looked at 8 being greater than 8, it was false. So we've already evaluated this part of the statement. But what we have now is also this equal to. And is 8 equal to 8? That would be true. So is 8 greater than or equal to 8? This is a true statement. So this is a nice little example showing how these hybrid symbols work. We evaluated it for greater than 8, which made it false. But because it is true for the equal to 8, we can say that this entire statement is true. Each expression on either side of the inequality sign evaluates to 8, because the inequality sign states that the expression on the left side can be greater than or equal to, that hybrid symbol then, greater than or equal to, then the number sentence is true. We've already proven that 8 is equal to 8. And now we have a little challenge here, a little thinking. Can we find a number other than 3 that we can substitute for x that will result in a false number sentence? So is there something I could stick in here so that it could be false? Well, if I stop and think about this for a minute, I need a situation where x added to 5 will not be greater than or equal to 8. So what if I put a 1 in? And I'm just going to quickly set up a small t-chart here, places that we're going in the future. So I've got 5 plus x, and I've got the statement is 5 plus x greater than or equal to 8. So if x is 0, then my value of, let's see here, x, I got to set up more than a t-chart here. Overdoing it here. All right, so I've got x is 0, so 5 plus x would be 5, and is 5 plus x greater than or equal to 8? And that's a false statement. What if I put in 1? 1 plus 5 is 6. Is 6 greater than or equal to 8? It's a false statement. So I could explore, using a chart, different situations when it would be true and when it would be false. All right, so now we're into the exercise section. And this is very similar to what we did on the example. So we are going to substitute a value, and we're going to state in a complete sentence whether the resulting number sentence is true or false. If it's true, we're going to find a value that would make it false. If it's false, we will find a value that would make it true. So first step is to substitute. 4 plus 8 equals 12. 12 equals 12. This is a true statement, but I'm supposed to say this in a complete sentence. I'm not just supposed to simply say it is true. I need to add a little bit more here. So when 8 is substituted, for x, the number sentence is true. Now if it's true, which it is, I need to find a value that would give me a false number sentence. When 1 is substituted, for x, the number sentence is false. All right, exercise 2. So we have an inequality here, and the directions are the same. So I need to substitute 4.5 for g. So I've got 3 multiplied by 4.5, and I am answering the question, is that greater than 15? So it's a good thing that we've spent some time this year working on multiplying with fractions. A couple of different ways I could do this. I'll do what is probably most commonly done. I will take my fraction and turn that into a mixed number. 2 times 4 is 8, plus 1 is 9. So I've got 3 multiplied by 9 halves. And 3 times 9 is 27 halves. And 27 divided by 2 is 13 and a half. And I am asking, is that greater than 15? And the answer is no. It is not. This is a false statement. And to save time in this video, I'm not going to write out all the sentences, but I will try to verbalize them. If 4.5 is substituted for g, this number sentence is false. Now I'm supposed to find a situation where this would be true. So over here is the false side, and now I need to find a value for g that would make it true. 3 times g is a number that is greater than 15. Now if I stick in a 5, 3 times 5 is 15, but that's not greater than 15. I need a number that will give me a value greater than 15. So I could put in a 6. 6 times 3 would be 18. So I could say that this is true if I used 6. So find a value, find a value that would result in a true number sentence. If g were 6, this number sentence would be true. All right, here we go. We've got f divided by 4 is less than 2. Sometimes when I run into these division problems written horizontally in text, I like to recopy them into the fraction form. And it says I will substitute 8 for f. So 8 divided by 4 less than 2. Well, 8 divided by 4 is 2. Is 2 less than 2? This is a false statement. When 8 is substituted for f, the number sentence is false. Now I am supposed to find a situation where it would be true. So I need to substitute in a number that if I divide it by 4, it will be less than 2. F divided by 4. So let's see, if I had f before, 4 divided by 4 would be 1, and 1 is less than 2. So I could say that if f were equal to 1, the number sentence would be true. All right, taking a look here at exercise 4, same process. So I've got 14 and 2/10 is less than or equal to, and my value for h is 25 and 8/10 minus 10 and 3/10. So a little bit different than some of the other ones. We actually have our variable on the side where we've got some of the operation performing, although I guess some of the other examples did that too. So I guess you can forget that I said that. So I've substituted in, and now I need to evaluate 25 and 8/10 minus 10 and 3/10. And I've lined up my place values, ones with ones, tens with tens, tenths with tenths, decimals with decimals. 8 minus 3 is 5. Make sure that decimal moves with me, and 25 minus 10 is 15. 14 and 2/10 less than or equal to 15 and 5/10. And this is a true statement. If h is 25 and 8/10, this statement is true. Now I need to do something to make it false. So this side was true, this side is false. So I need to have a situation where I've got 14 and 2/10 is less than or equal to a value of h subtract 10 and 3/10. So I need to subtract something that's going to leave me something greater than this 14 and 2/10. Well, when I subtracted 25 and 8/10, I was left with 15 and 5/10. And 14 and 2/10 was less than that. So I'm wondering, should I use a number greater than 25 and 8/10 or a number less than 25 and 8/10? Well, I'm thinking if I do a smaller number than 25 and 8/10, and if I take about 10 away from it, that I will be in a better situation than if I use a bigger number. So I'm going to make this even easier, and I'm going to say, what if h is 14 and 2/10? So I've got h is 14 and 2/10, and I've got h minus 10 and 3/10. 14 and 2/10 take away 10 and 3/10, and do a little bit of regrouping here. And I have a difference of 3 and 9/10, and I could say that 14 and 2/10 is not less than or equal to 3 and 9/10. Now just a quick explanation of what I came up with here. I wanted something less than 14 and 2/10, and I said if I take 14 and 2/10 and substitute it for h, and then I take something away, then of course I'll have less than 14 and 2/10. All right, we have 4 equals 8h, and we are going to substitute 6 for h. 4 is equal to 8 divided by 6. Now already in my brain I'm thinking this does not work, but we're going to follow it out here. So 8 divided by 6, and I'll get 1 and 2/6, which is equal to 1 and 2/3. And I can definitively say that 4 is not equal to 1 and 2/3. So this is most definitely false if h is equal to 6. So I need to come over here and come up with a true statement, and I need to find a number that I can substitute for h so that when I divide 8 by it, I will get 4. So I've got h, and I've got 8h, and I am looking for a situation where I would be left with 4. Having a value of 4. So let's see here. If I put a 1 in, 8 divided by 1 is 8. Well, that's definitely not going to work. What if I put a 2 in? 8 divided by 2 would be 4. So it would be true if h equals 4. All right, taking a look here at exercise 6. And I've got 3 is greater than 1½ plus 1/4. So I need to add this mixed number here to this fraction, and I'm very comfortable working with halves and fourths together, and I know that it's going to be 1 3/4, but just a quick walkthrough of how I could solve that if I didn't know how to do that. I need common denominators, so I have to take the half and I need to scale it up to the least common multiple of 2 and 4, which is 4. So 2, 4, and so here's my multiples of 2 and my multiples of 4. So my 1/2 scaled up, so I'll multiply it by a fraction equal to 1. So 2 times 2 gives me the 4, and 2 times 1 gives me the 2, and now I have an equivalent of 1 2/4 plus 1/4, which will give me 1 3/4. And 3 is greater than 1 3/4. So this would be a true statement if the value of k is 1½ Now I need a situation where it is a false statement. So I need to add something to 1/4, and I need to have less than 3. Well, I'm all about keeping things easy. What if I just add 1 to a fourth? So I've got k, and I've got k plus 1/4. What happens if I add 1? Well, 1 plus 1/4 is 1 1/4, and 1 1/4 is not greater than 3, so I have created a false number sentence. 1 1/4 greater than 3 is false. Now hopefully you're starting to see some patterns emerging for these true and false statements, but not a huge emphasis at this point, but things to be watching for. All right, here we've got 4 5/10, and we are going to substitute 2 5/10 for D, and we are answering the question, is that greater than 2 5/10? 4 5/10 minus 2 5/10 would be 2, and is 2 greater than 2 5/10? No, it's false. So this number sentence is false if the value of D is 2 5/10. So I need to have a situation where it is true. So I'll have D and 4 5/10 minus D. And I want to be greater than 2 5/10. Well, I subtracted 2 5/10 to start with, and I was left with 2. So I'm thinking here that I should take away less than 2 5/10 because I want to be left with a whole lot more than this 2. So maybe I'll do D D is 1. 4 and 5/10 minus 1 is 3 and 5/10, and now I have a true statement. I know if I do 2, that I will have 2 and 5/10, and now all of a sudden, so it was true in this situation, now all of a sudden it's false. So taking a look at the pattern here, I was okay with 1, I was not okay with 2. If I put in 0, 4 and 5/10 minus 0 is 4 and 5/10, and now I'm true. So I'm noticing, well, let's put in a 3 here, which would leave me with 1 and 5/10, which would be false. So I'm noticing if I have numbers 2 or 3, it's false. If I've got 1 and 0, then it's true. So I can start to see some patterns here to maybe use later. All right, here we go. We've got 8 is greater than or equal to 8 is greater than or equal to 32 times half. And half of 32 is 16. And I can say that 8 is definitely not greater than or equal to 16. Most definitely not. So I need to come up with a situation where it would be true. So I need to multiply 32 by something so that 8 can be greater. So 8 is greater than or equal to 32p. I've got p here, 32. So I multiplied by half and the number was too big. If I multiply by 1, the number's still too big. So I'm thinking that I need to be multiplying by something less than the half. Probably a lot less than the half. So let me try 1/4. 1/4 of 32 is 8. Can I say that 8 is greater than or equal to 8? Yes. So it would be true if the value of p is 1/4. All right, we've got w, which is 16, divided by 2 is less than 32. And 16 divided by 2 is 8, and is 8 less than 32? So it is a true statement if the value of w is 16. Now I need a situation where it will be false. So I'll have w, and I'll have w divided by 2. So I need a number that when I divide it by 2, it's going to be bigger than 32. Now I'm thinking in my head here that if even I take 32, if I put 32 in for w and divide it by 2, I've got 16. And 16 is still less than 32. I need to get a number even bigger than 32. So I figure I've got to at least double the 32. So 64 divided by 2 gives me 32. And now I'm equal to 32, but I'm supposed to be greater than 32 because I'm trying to have a false statement here. So I've got to pick something even bigger. So I could do 66 divided by 2 is 33. So if the value of w were 66, this statement could be true. All right, we've got 18 is less than or equal to 32 minus 14. 18 is less than or equal to, and 32 minus 14 is 18. So this is a true statement. It is true. This statement is true if the value of b is 14, because 18 is equal to 18. But now I need to have a situation that is false. I need to subtract something and not be less than or equal to 18. So I took 14 away and I was equal to 18. So if I take away something less than 14, perhaps it will work. I'll do a 1 here. That's less than 14. 32 minus 1 is 31. Well, 31 is not less than or equal to 18. 32 less than or equal to 18? False. What if I do a 5? 32 minus 5 is 27. And 27 is not less than or equal to 18. Another false statement. All right, so a little bit of reflection here. We've gone through and played with a whole bunch of number sentences, equations, and inequalities, finding situations where they're true, finding situations where they're false. So looking back at exercise 1, we had 4 plus x is equal to 12, and we substituted 8 for x. And the question is, what did we determine here? What did we figure out? And we figured out that when we substituted in the 8, 4 plus 8, we found that the number sentence was true. And when we tried to substitute in some numbers to make it false, we found that if we picked anything other than 8, if I could do a 4 plus 9, or a 4 plus 7, or a 4 plus 8 and 1/10, in each of these situations, it would be false. So we found that in this situation, there was only one number that would make this true. And we had a whole bunch of numbers that would make it false. Something interesting to do is to stick in a 0. 4 plus 0 equals 12. I love seeing what happens when I'm at 0. And of course it was still false. But once again, the big idea here is that there was only one number that we could put in to make this true, and that was 8. And of course, a hidden message there is if you have an equal sign, there is usually only one correct answer. Now, I say usually because when math gets a little bit more complicated, there are more ways that are possible to make it true. So when we substituted 8 for x, the number sentence was true. We tried to find values to substitute for x that make the number false. And in class, we'd have a discussion about what did you substitute in. What happens with 0, 1,000, a trillion, what about a fraction? What about a decimal? And we would find that no matter what we put in, if it's not 8, it will be a false number sentence. Which leads us to the conclusion only one number can be substituted to make the two expressions equal, and that number is 8. And of course, we've already played a little bit this year in Module 2, Module 3 with absolute value. We could do an absolute value, and that would also be true. So just letting you know that in the future you're going to see some more things that might make it possible to be true. All right, so inequalities. Let's take a look at another exercise. Exercise 2, 3g is greater than 15. And we substitute 4.5 for g, and we determined after we evaluated the inequality that it created a false number sentence because 13.5 is not greater than 15. In class, we'll have a discussion about what number students substituted to make it true. And we'll have a discussion about what about all of these other numbers? Would they also make it true? And what we would find is that all of these numbers would make it true. I could stick in any one of these, and this statement would be true. 3 times that number would be greater than 15. So we could conclude that as long as we picked any number greater than 5 for the variable g, that the number sentence would be true. So on the last example that we looked at, exercise 1, there was only one number that made the statement true. Here we have a situation where we have a whole bunch of numbers, an infinite number of numbers. As long as it's greater than 5, the number sentence would be true. And if we were picking anything, what makes it false? If we were picking anything equal to 5 or less than 5, that it would be false. And that should say any number less than or equal to 5. So think about a number line for a moment. And if we can only substitute numbers greater than 5 on the number line, what would that number line look like? So here's my 0, 1, 2, 3, 4, 5. And I need to choose numbers greater than 5. So my number line would look like this: anything greater than 5. All right, just a quick summary of some of the vocabulary. A number sentence is a statement of equality or inequality between two numerical expressions. And so we had all those symbols that we looked at. Truth values of a number sentence. A number sentence is said to be true if both numerical expressions evaluate to the same number. It is said to be false otherwise. True and false are called truth values. Is it true? Is it false? Number sentences that are inequalities also have truth values. For example, 3 is less than 4, and 6 plus 8 is greater than 15 minus 12. And then we have 15 plus 3 squared is less than 1,000 minus 32. These are all true number sentences, while the number sentence 9 is greater than 3 times 4 is false. So we evaluate to determine if a statement is true or false. All right, so wrapping up the lesson, hopefully you can use these inequality statements, well, equality and then inequality statements. Hopefully you can determine if a number sentence is true or false. A deeper layer there is hopefully that you're starting to see some patterns, being able to decide when there will only be one number that makes a number sentence true, and when there might be many numbers that make a number sentence true. Quick look at our learning target again. Using substitution to determine whether a given value makes an equation true, and of course we're also including this inequalities in this. So at this point you would want to work on your problem set, double check your exercises, and if you've got questions, make sure that you talk to your teacher. And of course the next lesson is a continuation of this exploration.